Earth receives a signal every 44 minutes. Now we know where it's coming from. Space is big, mind-bogglingly big, and we have no idea the scope of what's out there. So when the Earth is receiving a signal every 44 minutes, experts are very keen to get to the bottom of it. So, what exactly is going on? What is sending the signal? Sorry to dash your hope of alien contact, but we now know that the signal is coming from a very unusual star that sits very far from Earth. ASKAPJ 18,320,911 sits around 15,000 light-years from Earth and lives deep in the galactic plane of the Milky Way, in a region of stars covered in gas and dust. When researchers at NASA's Chandra X-ray Observatory were making observations with their advanced CCD imaging spectrometer, something strange happened. They found a previously unidentified source of X-rays. The object is known as a long-period radio transient, or LPT, and is an astrophysical object whose brightness keeps changing. Only a small number of LPTs are known, and the first one was only spotted in 2022. The radio wave intensity of ASKAPJ 1832 cycle every 44 minutes, and it was very bright in radio at the time of observation. Most excitingly for scientists, LPTs had never before been observed, emitting both X-rays and radio waves. Astronomer Dr. Zhaidong Wang from Curtin University in Australia, who led the team of researchers, wanted to find out more and observe the object with ACIS and the follow-up telescope on board ESA's Einstein probe. However, the intensity of the star had decreased, and so had its luminosity. He said, ASKAPJ 18320911 is currently the only LPT detected with X-ray emission, perhaps unsurprisingly, given its extreme radio brightness and the potential correlation between the radio and X-ray luminosities. What could it be? ASKAP is a type of star. However, researchers are unsure which kind of star. It's thought to be compact and have a strong magnetic field, which would have the same checklist as a white dwarf, a corpse star that has shed its outer layers, or it could be a pulsar, which is a rotating neutron star that is highly magnetized. However, then there is an issue with its pulses. There is a chance that the star may be a binary white dwarf system, as white dwarfs are sometimes found locked in binary systems with other low-mass stars. But the radio emissions from these types of stars are usually weaker than those from ASKAP. So, Dr. Wang has given another option, and thinks that it could be a magnetar. A magnetar is an isolated neutron star, which has a powerful magnetic field, and properties such as varied pulses, and a radio spectrum that is constantly changing. They are known to throw tantrums, but it seems that ASKAP also slightly differs from them too, as it has a quiescent X-ray luminosity, and its low luminosity when its rotation slows down doesn't fit into the same category either. Older magnetars act more like this, however cannot reach such bright radio extremes as ASKAP.